This video is going to be just quickly showing you how we can solve a system of equations graphically. So let's go ahead and get started. I'm going to do a couple of the problems off the worksheet with you. I'll show you some tips in the calculator, and then I'd like you to try the others. Make sure you're very comfortable with it. I believe it's review from last year, but just in case it isn't, that's why I wanted to do this video with you. So if we look at problem number 5, they give me 2 equations. If you have 2 or more equations, this is what's referred to as a system of equations. And when we're trying to solve a system of equations, we're looking for the intersection of these 2 equations. So I'm going to start with this first one up here, x plus y equals 0. I want to graph this by hand. So in order to graph it by hand, I need to know my slope and my y-intercept, which means I will need to get y by itself. In order to do that, I'm going to move x to the other side by subtracting it. This will give me y equals 0 minus x. When I go to graph this, the number that's by itself, the constant, that's my b value. That's my y-intercept. The coefficient of x, in this case, -1, that's my slope, m. So to graph this purple line, now that y is alone, I'm going to begin with b, which is 0. I'm going to move with m. This is -1 over 1. Because it's negative, I'm going to move down first and then forward. So from my y-intercept, I'm going to move down 1, forward 1, plot a point. And I'm going to keep doing that. It is really important when we start graphing systems that you plot every single point that you possibly can and that you plot them very carefully. Accuracy is very, very important with systems. And then I'm going to sign my line. So my equation, it doesn't matter if you use the rewritten one or if you use the original. I'm going to use my rewritten one. That purple line is the graph of y equals 0 minus 1x. The second equation I have is 3x plus y equals -4. Once again, if I want to graph this using slope and y-intercept, I need to get it into y equals mx plus b form. This requires me to get y alone. I'm going to move the 3x by subtracting it from both sides. These are not like terms, so I cannot combine them, which means my right-hand side is going to be -4 minus 3x. And now y is by itself. B is my constant. Remember, we begin with b, so that's my y-intercept, which is -4. That would be right here. We move with m. M is the coefficient of x. That's our slope. That is -3 over 1. Since it's negative, I'm going to move down first and forward. So from my y-intercept, I'm going to move down 1, 2, 3, and forwards 1. Now, I know I've run out of graph, but I want to put that there because that helps me see that to get more points, I can move up 3 and then backwards 1. Then I'll keep going, up 3, backwards 1, up 3, backwards 1. And if I connect those points, I get my second line. The equation of this line is y equals -4 minus 3x. So now I've graphed them. What is the solution? Well, the solution to my system of equations is the point of intersection. The point of intersection is -1, 2. So my x value is -2, and my y value is +2. So my solution is -2, 2. That is the only point that these two lines have in common. So that is the solution to my system. Now, in case you want to figure out the answer to the witty joke at the top, it says solve each system below, cross out the box containing your answer. So we just got -2, 2, so I'm going to cross off that box right there. Okay, next one, we're skipping to number 8. In number 8, y is by itself. I have y equals -2. This is y equals a number. There is no x. I find it helpful to just remind myself, I can set up a table for this. Y is -2 no matter what. So when x is 0, y is -2. When x is 1, it's -2. When it's 2, when it's 3, and so on. So 0, -2 is this point right here. 1, -2 is here. 2, -2 is here. And I can see this is going to be a horizontal line. Do not forget to sign your line. And don't forget to put arrows on the end. My second equation is 2x minus 5y equals 20. If I want to graph this without my calculator, I would need to get y alone. I would like you to see how we could use the calculator to do this as well. I will come down, we're going to open a graph page. Because y is not alone, I'm going to press delete and select relation. And I'm going to go ahead and type in 2x minus 5y equals 20. If I hit enter, I get my line. Control T is how we see a table. When I do that, though, it says we can't get a table because it's not a function. We haven't defined it as a function. Instead, remember the other way we can get points is by going to Menu, Trace, and selecting Graph Trace. The first point I get is 0, -4. So that will be the first point I graph. 1, 2, 3, 4. There's my first point. Then I'll go ahead and try typing in 1. That's not a nice point. I'll try 2. Still not good. 3, no good. 4, no good. Oh, there we go. 5, -2 is a nice point. So 1, 2, 3, 4, 5, -2. And what I see right there is there's where my two lines intersect. Don't forget to sign your line. I'm going to label this with the exact same equation that they gave me. I'm not done until I actually list my solution. Circling that point is not enough. I would strongly recommend that you write the solution is, in this case, it would be 5, -2, because that is the only point that is on both lines. If I come over here, 5, -2 is this F, F, I can cross that off. Okay, you should be able to do the rest of these. It's excellent practice. And we are going to focus on the algebra of solving these when you come back next class. Have a great day.